have chemistry part, okay, so which is online paper. So here 40 questions are there, all the 40 questions should be attempted, okay. So let's see and let's start our session. Here first question we have, according to Bohr theory of hydrogen atom, the approximate angular momentum of electron in hydrogen atom, okay. So how can we do this kind of questions, okay. So here we have, look here, so this is a question I am discussing here. So let me check once everything is going well or not. Yeah, so this is a question we are discussing here. So Bohr model, so according to Bohr model, angular momentum we need to calculate. So how can we do for hydrogen atom in ground state? So angular momentum L equals to, we have NH by 2 pi. So only those orbits are allowed in which their angular momentum is an integral multiple of h by 2 pi. We are studying about this now in the Bohr model. So where n represent the energy levels or the shell numbers, right. So since they are saying ground state, so n equals to 1. So angular momentum L equals to 1 into, what is the value of h here? Planck's constant, they only mentioned here, take it, 6.62 into 10 power minus 34 joule second, okay, by 2 into, what is the pi value? So pi equals to 3.14, okay. So you can cancel out this, therefore we can get it is around 0.5. So angular momentum equals to L equals to 1.05 into 10 power minus 34 joule second. So this is our answer. So do we have any option like that? Yes, 1.05 into 10 power minus 34 joule second is the second option. I hope it is clear now. So let's move further. So 122, question number 122, okay. So observe the elements from hydrogen to calcium, and how many elements have no unpaired electrons in their ground state. So how can we do this? So how many elements have no unpaired electrons? So you can take this hydrogen atom first, okay. So hydrogen atom, what is the electronic configuration? 1s1. They are saying how many electrons, how many elements have no unpaired electrons? No unpaired electrons. See, it has one unpaired electron, okay. They are saying no unpaired electron. So no unpaired electron means beryl, if we take the second group elements, hydrogen, lithium, all this contains one unpaired electrons because their general electronic configuration is ns1. So like this, unpaired electron should not be there, okay. They are saying no unpaired electron, but here we have one unpaired electron. If we say second group elements, what we have? Beryllium, magnesium, these things now. So second group elements if we take, so they have ns2, there is no unpaired electron here. So these two elements, because this is atomic number 4, this is atomic number 12. So like that we have to start from atomic number 1 to atomic number 20, okay. Same, so based on this model only, there is one question in the 29th afternoon shift, okay. This is 29th morning shift, that is 29th afternoon shift. Both are containing same level of questions, and you know, same concept they have covered here, okay. So it is better you have to watch complete video, complete lecture of this, and also you can try questions from that topic also, that paper also. Therefore you will feel somewhat confident, okay. So you can also confirm, you can just confirm and tell me in the comment box whether two papers are same or not, okay, similar or not, okay. So from atomic number 1 to 20 if we consider like this, so second group elements have 0 unpaired electrons, next third group will be having, 13th group boron family will be having p1 electron. So like that, it means in p orbital one unpaired electron. Like that if we consider again in halogens, no unpaired electrons, like not in halogen, in inert gas we have no unpaired electrons because helium it is having ns2 configuration, right, and the next neon, argon, okay. So these two having ns2 np6 electronic configuration, okay, right, okay. So what are the elements here? We have helium, neon, argon, here beryllium, magnesium. Is there any other element? Again, so they are saying up to calcium now, so you have to take calcium also, 20 elements. So up to 20, these are the elements which are having no unpaired electrons. So these are 3 and here are 3. So total how many? 6, that's it. So we have option number 1 as 6, that's it. That is your final answer, right? So let's move forward. Among lithium, sodium, sulfur, oxygen, lithium, sodium, sulfur and oxygen, the elements have most negative electron gain enthalpy. So we know more electronegative atoms will be having more electron gain enthalpy, more negative electron gain enthalpy. So out of sulfur and oxygen, so down the group electron gain enthalpy increases for second period and third period elements due to large size, due to large size than this oxygen. Sulfur is having more easily it can accept the electron, so therefore it releases more energy. So I can say the tendency to accept the electron is more for sulfur than the oxygen, therefore more negative electron gain enthalpy is for sulfur. So write for sulfur, then next oxygen. Now out of this lithium and sodium, these are alkali metals, right? So down the group metallic nature, what happens? Metallic nature increases, they have less tendency to accept the electron, more tendency to release the electron. Here electron gain enthalpy means what? So tendency to gain electron. So if it is having more tendency, more energy will be released, right? So but lithium is small size, more effective nuclear charge will be there, easy, like relatively it will be having more tendency to accept the electron than the sodium, therefore I am writing lithium, sodium. So choose the option which is having in this order. So what they are asking us, most negative is for sulfur, least negative is for sodium, that's it. These are the two species, okay. So you can choose the option C, option 3 is having sulfur, sodium, that's it, that is your answer, okay. Next, enthalpies, ionization enthalpies of X, Y, Z are given. They are saying that atomic numbers are successive, so one after the other, okay, and their electron gain enthalpy values are like this, okay. So like this. So now we need to identify which elements these are. So X is having relatively higher electron ionization enthalpy, then Z is having more electron gain enthalpy than the Y. So it means maybe there is a stable electronic configuration for Zx, therefore it is having high electron ionization energy, it is having high ionization energy. So now we know in the first group they see, just see, so lithium, like sodium is given first, but X is having maximum, but sodium will be having minimum in the given order, because sodium is alkali metal, easily loses electron, therefore first option is incorrect. So if we go for this, X is having highest, so noble gases are stable electronic configuration containing species, so they will be having highest ionization energy. Then minimum for Y, so that's why it is alkali metal, because alkali metals are having low ionization energy than the second group elements, alkaline earth metals, because they are having NS2 electronic configuration, this having NS1, okay. So this fully filled s orbital electron is strongly bounded to the this magnesium, nucleus of this atom, therefore it is hard to remove the electron when we compare with the alkali metals, therefore this order is correct, okay. So neon maximum, magnesium, then next sodium, that's it, this is our order, okay. So that is there in the option number 2 only, based on the values, okay. So let's go further. So here you can see what they mentioned, which of the following statements are correct. So increasing order of covalent character for these 3 substances, okay. So these are 3 are ionic compounds only, but every ionic compound there will be some covalent nature, what they have, some covalent nature. So this covalent nature is explained from Fazan's rules. What is that? Fazan's rules, okay. So what according to Fazan's rule is, cation should contain small size cation, okay, small size cation, and large size anion, okay. So this resulting composition, this resulting combination will give us more covalent character compound. So that compound will be having more covalent character. Now look here, chlorine, chlorine, chlorine. So anion size is same, but cation sizes are different. Here it is having +2, here it is +1, this is +1, okay. Now Mg is having like more positive charge, so small size, okay. So this is having small size, so small size cation with anion will be having more covalent nature, right. So one is correct. So out of rubidium and sodium, sodium is smaller in size, so the respective cation small size with one anion, therefore it will be having more covalent nature than this last option. Okay, the order is correct. So first option is correct. Okay, so multiple options they are asking. Okay, then second option, high boiling point of water is due to intramolecular hydrogen bonding. So this is because of intermolecular. What is that? Intermolecular, but not the intra. So you can eliminate option 2. Let's go with option 3. Water has more dipole moment among ammonia, water and HF. Yes, that is true. Okay, you can go with 1 and 3, which is option number 1. Okay, let's move further. Identify the pair in both molecules do not possess same type of hybridization. So it is easy again from chemical bonding. So what it is saying here, water. So what is the hybridization of water there? It is sp3. For SO2 it is sp2. So how can we do? So just take the central atom. How many valence electrons are there in the central atom? So here oxygen, sulfur, both belongs to 16th group now. So valence electrons are 6. So take 6 electrons like 6 dots. 3, 3, 6 over. So how many atoms are there here? 2 hydrogen atoms. Okay, here one hydrogen, here one hydrogen. So this is one set of lone pair, this is another set of lone pair. These two are sigma bonds. So total number of sigma bonds are 2. Total number of lone pairs are, again those are also 2 lone pairs. So total hybridization number will become 2 plus 2, 4. So that is sp3 hybridization. Hope it is clear. Now for SO2, sulfur having 6 electrons, write it in this format. Okay, so now this oxygen is divalent, so to write one sigma bond, one pi bond. Similarly, one oxygen again sigma pi and one set of lone pair here. One set of lone pair. So just 6 electrons you can take. 1, 2, 3, 4, 5, 6. So this is a lone pair. So totally how many sigma bonds? 2 sigma bonds plus 1 lone pair. So totally 2 plus 1, 3. So sp3 means one is S, remaining are P's. sp2 hybridization. Like that you can do. So for PCl5 it is sp3. For ammonia it is sp3. So they are asking not possess same. So in the first option they do not possess same. They have different. But in second option they possess same hybridization. In third option also they possess sp2 hybridization. So sp2, that is also you should not consider. So BCl3 having sp2, NCl3 having sp3. So first and fourth options are correct. So you can go with the last option 1 and 4. Okay, that is our answer for this question. Let's move further. Okay. So PV graphs. PV equals to nRT you can take and you can do this. Okay, what they are asking, the two slopes, the slope of two lines. Okay, so if you solve this, like you can take just take PV equals to nRT and you can get this from it. Okay, so from these isotherms you can draw. So isotherms means what I can say, P equals to RT by V, right? So from this is a slope we can get. So from that if you solve, if it is 1:2 ratio, we will be getting 2000 as the answer. From this you can take the ratio by drawing the graph of P versus V. We are remaining with RT, RR cancel, you can get the T which is in the 1:2 ratio. From that T1 is 1000, so T2 you can calculate, which is 2 into T1. So you will be getting 2 into 1000, it will be 2000, that's it, that will be the answer. Okay, I hope it is clear, right? So let's move further. Here again, so temperature is mentioned, 100 ml of 0.05 molar copper plus 2 ion is given, added to 1 liter of 0.1 molar Ki. What is the concentration of Ki in the solution? So what in the resultant solution? So you just take Cu plus 2, to this we are adding Ki. Okay, so now what we can get from here? So from here we will be getting Cu. So if you take 2 moles and if it is taking 4 moles, we will be getting Cu2 I2 and I2 is liberated. Okay, so for every 2 moles we require 4 moles of Ki as per the equation here. Okay, now what we have? So what concentration of so aqueous solution, see 2 moles required, 4 moles of Ki na. So how many moles they have given? Molarity formula what we have, N by V. So number of moles means M into V we can write. Okay, so those are given as 100 ml milliliters into 0.05. So 5 into 10 power minus 2 I can write. So this will become 5 millimole. How many millimoles of copper? It is 5 millimole. So for Ki, so it is 1 liter. It means I can say 1000 ml into 0.1 molarity. Okay, so you can cancel this. So we are having 100 millimole. Okay, so for every 2 moles we required 4 moles of Ki. For every 1 mole we required 2 moles. It means 1:2 ratio. For every 5 moles we required 10 moles of this substance. Out of 100, only 10 moles is reacting. Okay, 10 millimoles is reacting. So again, how many is unreacted? Remains unreacted. So 90 millimoles are unreacted. So that is what we need to calculate here. So we have 90 into 10 power minus 3 millimoles of Ki is present in the resulting solution. Okay, that is what the extra concentration we have. Okay, now this concentration, this many moles present in total volume of 1 liter. It means 1000 ml, 1000 plus it is 100. So totally 1100 ml we can consider here. So how much I am taking? So 1100 if I take, 1100 ml if I take, you can multiply with 1000. So 0 0 cancel. So I can write 1.1. So this I can also write it as, so I can also write it as 0.09. Okay, 3 zeros we should insert now. 90 into this means we can write like this, and in the denominator we have 1.1. So that is what the option here we have. Okay, so whatever the format they mentioned, you try to convert into that, so you will be clear with the options. Okay, so let me check, anyone in the comment box writing anything? No one. Okay, so you can write anything. If you are having any difficulties, you can mention in the comment box. Okay, then let's move further. Identify the correct statement from the following. Energy of an isolated system is constant. Okay, is that correct? Yes, I feel it is correct only. So what the first law of thermodynamics says? The energy of an isolated system is constant, right? And second law we will be studying that entropy of a universe or entropy of an isolated system always tends to maximum or increases. That is what the second law says, and this is what first law. It is also correct. Okay. Now in a closed system, exchange of both energy and matter takes place. No matter exchange, only energy exchange takes place. So this statement is incorrect. So enthalpy is exothermic process. That is correct. 1 and 3 are correct. So option 2 is correct. From the data given, 1 and 3 are correct. Okay. I hope it is clear. Let's move further. So this is a reaction given. So equilibrium reaction, and it is having Kp value as 4 into 10 power 10. Okay, this is the Kp value. Now they are asking about Kp dash by giving this equation. So just observe these two equations which are taking place at same temperature. So what is the relation between them? See, it seems to be reaction is reversed. This reaction is reversed and multiplied by 3, multiplied with 3 and divided by 2. That's why here 2 is there now. So in order to remove this 2, complete equation is divided by 2, right? Right, completely divided by 2, and complete equation is multiplied by 3. Okay, after doing this, so what is the process they did? So they multiplied with 3 divided by 2. So totally it is 3 by 2. Okay, after doing this, they reversed the equation. So whenever an equilibrium reaction is reversed, the equilibrium constant will become inversed. So Kp dash will be equals to Kp dash will be, so Kp dash will be equals to, reaction is reversed I am saying now. So it means equation, this value will be inversed. You can write Kp. Okay, now complete equation is multiplied with what? Multiplied with 3 and divided by 2, right? That's it. This is the thing you have to consider. Now what is the value of Kp? So Kp is 4 into 10 power 10, overall 3 by 2, like this we can write. Okay, so now Kp dash will be, so 4 I can write 2 power 2, 1 by 2 power 2 into 10 power 10 into 3 by 2. So see, I can cancel this 2 and this 10 as 5 times, 5 2s are 10, that's it now. So now we got finally 1 by 2 into 10 power 5, we have multiplied overall with a cube. Okay, so what is a 2 cube? It is 8, so 1 by 8 into 10, 5 3s are 15, so 10 power 15, like this you can write. Now there is no option like that, so we need to change it into some other format. So 1 by 8 into 10 power 5, 15, I can write it as, so 1 by 8 into 10 power minus 15, so here I am taking 10, so I should divide with 10, so I am taking 10 power minus 16, like that. So this will becomes 1.25. Okay, so there will be an option like this, 1.25 into 10 power minus 16, that is our final answer. Okay, let's move further. I hope everything is clear without any confusion. Yes, let's move further. So for stabilizer, see, H2O2 hydrogen peroxide easily decomposes, like to form H2O and oxygen gas is liberated from it. Okay, so that's why in order to make it to not undergo decomposition, to stabilize it, we will be using stabilizers. So stabilizer here we will be using is urea. So what is a compound we will be using as a stabilizer? Urea is a stabilizer used for this H2O2 as a stabilizer. Okay, that is a direct question again. Again here also sodium bicarbonate, yes. So in fire extinguishers, sodium bicarbonate is used. Okay, so sodium bicarbonate present in the fire extinguisher, that cylinders. So at the top there will be sulfuric acid. So this, whenever that knob is pressed, that sulfuric acid will falls into the sodium bicarbonate, and the reaction between this bicarbonate and sulfuric acid takes place and liberates CO2 gas, so which is used for the stopping or to put off that fire. Okay, so that is what the purpose of this sodium bicarbonate. Yes, this statement 1 is correct. When it comes to statement 2, so like Na2CO3, so that is used as a softening, used for softening of water. See, we know hard water, soft water is there now. So in order to remove the hardness of water, so that line Na2CO3 is used. Okay, you can remember that. Okay, that is also correct. So NaOH is used in the purification of bauxite, that is also correct. So all 3 statements are correct. So we have option 4 which is having all 3 statements are correct. Okay, then next, among the alkaline metal, the metal having least melting point, that is for magnesium. Okay, you can go with option number 3, because so here melting point depends upon interactions, I mean what kind of interaction it has, metallic nature as well as the crystal lattice structure also. So due to that reason it will be having lower melting point. Okay, so diborane, see guys, so guys, I before the exam, before this TS EAPCET itself, I have made a special video on diborane. So those who watched the diborane video, which is just a 10 minutes video, I know there will be at least one question. Yes, this is the question came in the exam. Okay, so if you haven't watched, there is a series called Golden Minute series in the playlist of our YouTube channel of this NEET world. So just go and look into it. Okay, so there I have covered this very clearly, so you can watch it and you can enjoy that session, so that you will get complete clarity about diborane. So now they are asking about industrial process of preparation of diborane. So what is the industrial process? So this will be the industrial process. All these processes are correct, but this is the industrial process. This is only industrial process in the given 3 options. So you can go with option number 1, which is having 3, right? This is based on inert pair effect. So group 14 is given. 14th group elements are given. They have electronic configuration as NS2, NP2. This is the general electronic configuration. So now down the group only NP electrons will take place in the reactions but not NS. Only the top elements in the periodic table will participate in, will take place for all 4 electrons, but down the group tendency to show reactivity in bond formation will be only for NP electrons but not for NS electrons. This is what the inert pair effect. How can we define the reluctance or the inertness of NS pair electrons to take part in chemical bond formation during the chemical reactions is called inert pair effect. Okay. So due to that reason, down the group +2 oxidation stability increases for group 14 elements and +4 oxidation state stability decreases. That's why, so if we see +2 oxidation state stability increases, I am saying down the group, and +4 oxidation state stability decreases. So down the group these are the elements: carbon, silicon, germanium, tin, lead, these are the elements. So down the group their +2 oxidation stability increases. This is correct. And here both are ionic in nature. PbI4, see lead, what I told you, that compounds will be like PbX2 type only, they will exist in the stable state. PbI4 does not exist because here it is having +4 oxidation state. So that is also correct. All 3 correct statements. 1, 2, 3, all 3 are correct here. Okay, next go through the next question. So increase in concentration of X in the pregnant woman, in the blood of pregnant women who have habit of smoking may induce a premature delivery. What is X? That is carbon monoxide. Okay, that is a general question. Carbon monoxide. What is the IUPAC name of this compound? So how can we give? Here we have methyl, here we have methoxy group. So both are substituent now. So both are substituents means methoxy, as per the alphabetical order methoxy comes first, right? So I can go, so the general name, if we do not have this, so I can say if there is methyl group, so we should call it as, if there is methoxy group, we should call it as anisole. Upon, like on benzene ring, if methoxy group is present, we should say it as anisole. If this one is there without methoxy, if only methyl group is there, we should say toluene. Okay, so now we should call it as anisole. Okay, 1, 2, 3, 4. So 4 methyl anisole. So 4 methyl anisole. We have option number 3, which is 4 methoxy anisole. Okay, 4 methyl anisole. So sorry, 4 methyl anisole, which is option number 3. And the next, here we have phenol, like hydroxy group and amine. So we know priority is more for alcohols. So we can call it as phenol ring with third position amino. So 3 amino phenol. So 3 amino phenol. That's it. Both options here. Option number 3 is correct for this particular question, right? I hope it is clear. This is the correct one. Next, guys, in the last paper also there is a question on KMNO4. There I think 2 or 3 questions are there in KMNO4. Again this question paper also there are almost 4 questions on KMNO4 oxidation reactions. Just on this one, just look into the discussion. This is one question. I will show you the remaining questions also. Check here. So butane is given. So KMNO4 they have treated. So always remember when this butane, this is alkane, na butane. So whenever we have an alkane, so like alkane I am taking, it is converted into oxidation process. I mean, so this is an oxidizing agent. So whenever we have alkane, so these tertiary, like this KMNO4 will only oxidize tertiary hydrogens only to respect to alcohols, like this. Okay, like this you can write. Okay, this alcohol treating with phosphoric acid. Okay, so treating with phosphoric acid means, so it will be undergoing dehydration. Remove one water, OH from here. Okay, so if it is undergoing dehydration, we will be getting a product. So okay, so what kind of product we are getting here? That is a question here. Okay, H3PO4. Okay. So let's see what's happening here. So this is the way we can say how many carbons are there. See, 4 carbons are there here. 1, 2, 3, 4, 5 carbons I have written. That's way. So let's retake this initial product, initial reagent. see. So first take 4 carbons. Okay, if I take like this, there is no tertiary carbon, na? So what I should do now, we have to create a tertiary carbon compound. So like this I can take. So here we have tertiary hydrogen. Now treat this with KMnO4. What it will do? It will be giving us alcohol here. So now treat this with H3PO4. Upon heating gives alkene as a product. So this is a product, alkene as a product. Okay. So this one upon treating with KMnO4 in a heating condition. So what we got? So this is the alkene we got now. So this upon treating with KMnO4 under acidic medium. So just cut this into 2 equal halves. Here we know here CH2 group is there. So just put oxygen above and below. Therefore we will be getting this as one product. And what about top side? So we have carbon. To that oxygen should be inserted. The directly attached hydrogens are there, na? That will be converted into OH. From this water elimination takes place. Like water elimination takes place, gives CO2 plus H2O. Therefore what are the product? We got acetone as a product. We got acetone. So from this, what I told you, from this if you break it like this, put oxygen. So we got acetone as a product, as well as CO2 gas is liberated plus water is formed. Okay, these are the 3 things. So we have option here. Okay, that is our option. Okay, I just wanted to look into screen whether it is able to visible or not. Same story here, KMnO4 given with alkene. What I told you to do, same story you can apply. Break this bond, put oxygen here and here, that's it, done. Next, if to these alkene carbons any directly attached hydrogens are present, convert into OH group. So what we are getting? CH3, CH. If direct H is there means we should write OH. Double bond is there, convert into OH. This is the product. Both side groups are same, so we will get 2 moles of this. So this is our X. Acetic acid is our X here. Okay. The next, what about Y here? So alkynes with sodium in liquid ammonia. So undergoes reduction and gives trans alkenes like this. Trans alkene. Okay, this is called a bridge reduction. BIRCH, bridge reduction. Okay. So where do we have this kind of option? I think we do not have here. So this is correct, but this is cis alkene. So this is not the correct one. So it means option number 4 might be the answer. Let us look into it. Yes, acetic acid we have, trans alkene we have. That's it. So trans alkene is a product formed in the bridge reduction. Okay. So in order to get cis alkenes, we should use Lindlar's catalyst. Okay. PD BaSO4 H2. Okay. Next. So an alcohol X, there is an alcohol X, okay, X let us say. So this treated with HCl, okay, at room temperature, gets converts into corresponding chloride. Okay, so we will getting some chloride here, some alcohol chloride. So this X, okay, again this X upon dehydration means removal of water. Okay, dehydration, this is alcohol. Okay, followed by ozonolysis gives Y and Z. So gives Y and Z. So Y followed by ozonolysis. Ozonolysis gives Y plus Z I am writing. Okay, let us look into it. Okay, so now reaction is taking place at room temperature. So what is this X, Y, Z we need to find here. What are Y and Z? So we need to identify X first. So at room temperature alcohol giving alkyl product means with how many carbons? 4 carbons. So I am taking tertiary alcohol, upon treating with acid forms, like remove this water molecule first and substitute here chlorine. So this is the tertiary chloride formed. Okay, this is happens in the room temperature only. Okay, so now this upon dehydration, here removal of water they are saying now, X upon dehydration. So here methyl group hydrogen and this OH you should remove as water. Therefore we can get this alkene as a product. Now this alkene on ozonolysis whenever you have ozonolysis process, just break double bond and insert oxygen both sides. Only oxygen where we have double bond, there you have to insert. So one is acetone, another one is formaldehyde. Acetone, formaldehyde, first option is correct, right? I hope it is also clear without any confusions. Okay, so place, this is the CH na, so place one oxygen upside downside, that's it, to the double bond. So this is happens in the ozonolysis process. I hope it is clear. Let's move further. Identify the crystal system in which body center lattice is not present. So body center in tetragonal, orthorhombic, cubic, body center will be there. In hexagonal, no body center, you can see. Okay. Then next, mole fraction of sulfuric acid in its aqueous solution is 0.9. What is the mass fraction? Okay. So now mole fraction of sulfuric acid is given. So mole fraction, let us say for sulfuric acid is 0.9. So how can I write mole fraction? So mole fraction is nothing but number of moles of sulfuric acid by total number of moles, n total we can write. Okay. So this is 0.9 means 9 by 10. Okay. Now how many moles of sulfuric acid here we have? Here we have is 9 moles by comparing this. Okay. So now from this we need to find mass percentage now. So that it means we require what is the mass of sulfuric acid first. So for that 9 moles are there. So moles we can write, moles of sulfuric acid we can write weight by its molecular weight equals to 9. So what is the weight now? 9 into molecular weight of sulfuric acid, that is 98. 98 is the sulfuric acid molecular weight. Okay. We got weight of sulfuric acid. Now total weight means we have sulfuric acid as well as aqueous medium. So we know the total weight of sulfuric acid, we need to find weight of water here. So weight of water means how many moles of water is there? So if it is 9 moles of water, out of this 10 moles, 9 moles of sulfuric acid out of this 10 moles, so 9 over, it means remaining one is water. So total number of water molecules are 1 and its molecular weight is 18. So 1 into 18 I am writing directly using this formula. Okay. So total weight is how much? 18 plus 9 into 98. This is the total weight. So in the numerator we should write weight of that component, whatever we want to find its weight fraction. Okay. So in this 9 into 98, okay, into 100. So if you do this, you will be getting around 98%. This is our answer. So how can we do? This is simple formula. If you want to find a weight of sulfuric acid, a percentage weight of sulfuric acid, you just take weight of sulfuric acid by total weight of all the components, total weight into 100, that's it. This is the formula I have used here. Okay. So we will be getting option number 3 as the answer for this question. Let's move further. Okay. So let me take some water here. Okay, let me check what are the questions we have. Okay, fine. Here for a first order reaction, A gives rise to P. So in this reaction the following graphs are given. So they are saying first order now, so rate is directly proportional to concentration of A we can write. So dA by dt, this is what the rate equation, right? So now we know the slope is okay. So greater the slope, I mean greater the value, so greater the slope, correct order of slopes. Okay. Obtain the slopes at point A, B, C are given. What is the correct order of the slope? Yes. So for first order it is more for A because greater the slope there. So MA is greater than MB greater than MC. Okay. You can directly understand it from the formula. So what is the integral equation here we have? So from that also, that only you can explain 1 by T, like this we have now, 1 by T ln A naught by AT, concentration at time T. So from this you can answer this question. Okay, then let's move further. Sorry. Give me some time. Okay. So following Freundlich isotherm absorption isotherm was obtained for a gas. Okay. So now the experimental condition for the graph between C to D. So from C to D, so how it is looking? It is a straight line. Say straight line like see here. So it is a straight line now. So it is straight line means it reached the saturation point. So I can say saturation due to high pressure of gas. So what is this? So due to its high pressure of gas. Yes, saturation of adsorption due to high pressure of gas. So here we have option number 2 for this question. Okay, so that is why the graph is like a straight line here. Okay, so you can also focus on Longmire adsorption isotherm and Freundlich absorption isotherm. What is physisorption, what is chemisorption from adsorption chapter. Okay, surface chemistry. Okay, so you can focus on these 4 topics. What is physisorption, chemisorption, what exactly adsorbent, absorbate, and the next Freundlich adsorption isotherm and Longmire adsorption isotherm. These are the 4 things you should focus from surface chemistry. Okay, when it comes to this question, which are the following metal is not correctly matched with its refining process. So here it is, vapor phase refining is not the correct one for copper. So remaining are correct only. Okay, then next for this match the following. Ozone, SO2, sulfuric acid and phosphine is given. So what are their uses? So here phosphine will be used for smoke screen. Okay, so in the warfares, so I can say D4. Next ozone is used as germicide, A3, D4A3 we have in first option. Okay, so let us SO3, sulfuric acid used in storage, batteries. Okay, so it means SO2 used as anti-clone. So do we have any option? We need to check. So what we got? A3B1, A3B1C2, A3B1C2. Yes, we have option number 3. So you can choose that option, A3B1C2. Okay. Then next, acidic strength. What happens? Remember here. So HF down the group, fluorine. We have fluorine, chlorine, bromine, iodine. These are the elements present in the halogen. Down the group. Okay. So small size fluorine having small size hydrogen. So their overlapping is very strong. Therefore bond strength is more. Okay. So therefore it is bond strength is more. So it will not give hydrogen easily when compared with the iodide and hydrogen iodide. So due to the large size iodide, small size hydrogen, the overlapping is very weak. So it will easily dissociate and gives H plus ion easily. Therefore which is more acidic? HI is more acidic. Down the group acidic nature increases. Strong acid is HI. This order is correct. Okay, why? The bond dissociation enthalpy of hydrogen halide is following this order. So HI required minimum energy, easy to break, easily gives H plus ion. Okay, I hope this is also clear. Both statement, assertion, reason both are correct. Okay, so let's look here. Assertion, reason both are correct. Okay, first option is correct. Next, among the following, among the noble gases, the most abundant in the atmosphere, that is what? Argon. Okay, this is a direct question, right? Next, the change in oxidation state when sulfur during the oxidation of thiosulfate in neutral alkaline solution of KMnO4. So what we can get here? So let me take yellow. So SO, no, not yellow. Let me take some pink. Okay. So sulfur, thiosulfate now. So thiosulfate means it is Na2H2O3. So H2O3 I am taking, sodium thiosulfate means Na2H2O3 we can say. Okay, so now when upon treating this with KMnO4, okay, so it will be in neutral or faintly alkaline medium, they are saying neutral alkaline medium. Okay, so here it is +2 oxidation state, so this converts into sulfate, -2 means here it is oxidation state is +6, so +2 to +6 conversion taking place. So here +2 to +6 conversion taking place, first option is correct. I hope this is also clear without any confusions, right? Okay, let's move further. IUPAC name of this complex, metal complex is given. So first of all, if you consider this coordination sphere which is in the anionic cationic position, now what are the ligands we have? Just identify them first. After that, follow their alphabetical orders. This is amine, this is aqua, this is chloro. Which alphabet comes first? Amine, AM comes first. So write tetra aqua, tetra aqua, tetra amine, amine, tetra amine. Then next aqua comes na A, na aqua. So aqua, no space in between the letters, in between this sentence like words. Okay, next chloro, aqua, chloro, next chloro. Okay, next cobalt, metal you should write cobalt. Okay, cobalt. So what is its oxidation state? Right here, see 2 chlorines outside, inside 1 chlorine, so totally +3 will be the oxidation state. So 3, cobalt 3, and outside the coordination sphere we have chlorines now, so leave some space, little space, leave a space and write cobalt 3 chloride. Okay, this is the name. Okay, so where do we have tetraamine, aqua, chloro, cobalt 3 chloride, that's it, this is our answer. Okay, that's it. So intermolecular forces, increasing order of intermolecular forces. So for this, more dipole movement, I mean dipole interactions, more polar is a compound, more it will be having more interactions. So 1 is more, then 3, then 2. So fourth option is correct for this question. Okay, then next. So vitamin C and vitamin E are sources for vitamin C and vitamin E are. So for vitamin C, citrus fruits we can say, and amla also correct. But for vitamin E, sunflowers seeds or sunflower oil is the best option. So option 2 will be correct for this. Okay, you can go with option 2. Next, correct. Identify the correct set of from the following. So ofloxacin, which is a broad spectrum and bactericidal. Bactericidal means what? So it has both effects, killing bacteria and also inhibiting the growth of that bacteria. Okay, so that is what we can say bactericidal. But bacteriostatic means it will just it will inhibit the growth of bacteria but not killing it, right? So bactericidal. So ofloxacin having correct explanation here. So both are this is correct. Okay, so you can go with the option number 2. Okay, then next, again KMnO4 question here, again third question on KMnO4. Isopentane is given. Okay, isopentane is given. Okay, 1, 2, 3, 4 isopentane. So here we have tertiary hydrogen. Upon treating with KMnO4 gives tertiary alcohol like this. So this is our X. So this X upon treating with Y giving chlorine. So this is just use HCl concentrated like that. So we will remove that tertiary alcohol using this acid and replace it with chlorine. That's it. Substitution reaction follows SN1 mechanism. Okay, so where do we have this is the alcohol. Okay, because we know only tertiary hydrogens will be oxidized by KMnO4 from alkanes, right? So correct, concentrated HCl, this is also correct. So option number 3 is correct for this. Let's move. Boiling point of diethyl ether is less than 1 butanol. Yes, so boiling point of 1 butanol having See, always remember alcohols having more boiling point than the other things. Why they have more boiling point than these ethers and aldehydes, ketones of similar molecular weight? Because of more extent of hydrogen bonding, greater hydrogen bonding in alcohols, therefore having more boiling point than the other. Okay, so this statement is correct. And diethyl ether is miscible with water to almost same extent as 1 butanol. Actually, yes, almost it is correct only, but we have seen it is 2 butanol, no issues. Maybe diethyl ether and also 1 butanol having almost similar miscibility. So both statements are correct here. Okay, last 3 questions. Isopentyl alcohol and reaction with reagent X. So what is isopentyl alcohol? So first of all you need to know what exactly isopentane. This is isopentane. Okay, isopentyl alcohol reaction with X gives corresponding carboxylic acid. Okay, so in order to give corresponding carboxylic acid, definitely it should be a primary alcohol. So I am placing it here. Okay, now so just what we need to do? So we need to use tertiary alcohol. So you need to you need to treat with some oxidizing agent, so that will give the corresponding alcohol. So let me take this and treat with KMnO4 in acidic medium. Okay, so this gives us COOH. This is a carboxylic acid formed. 1, 2, 3, 4, 5. Okay, this is a carboxylic acid formed. Okay, now from this carboxylic acid, upon decarboxylation means you have to treat this with NaOH plus CaO. Okay, upon heating, just remove the CO2 part and you will be having, so 1, 2, 3, fourth carbon is removed, this carbon is removed, 1, 2, 3, and you will be having like this. So this is one CH3 group, another CH3, another CH3, like this we got. Okay, now this is what gave Y. So this is our Y. Okay, it is also looking like Y only. Okay, now reagent with reagent Z gives tertiary alcohol. So what is the reagent? What is the reagent? See, here we have one tertiary hydrogen now. So if I use KMnO4 here in direct KMnO4, not in acidic medium, directly KMnO4 I am using. So what it will be giving? It will convert tertiary hydrogen to tertiary carbon containing hydrogen will be converts into alcohol. That's it. So option 2 is correct for this question. I hope it is clear. Here acidic KMnO4, here it is simple KMnO4 is used. Oxidation, see KMnO4 oxidizing reagent is one of the important. So in EAPCET I felt that they are more focusing on reagent parts. Okay, there are in the same paper there are 4 questions on reagent chemistry, especially on KMnO4. What are all the application given for KMnO4 in your 12th and 11th standard books? Okay, you just need to learn those. Okay, so this is about the one thing. Okay, so if you want to know more about this KMnO4, just go through hydrocarbon chapter where I have discussed everything. I mean most of the examples which are useful for this oxidation purpose, like KMnO4 and the next ozonolysis, ozone process, and also some other reagents I have discussed there. You can watch it if you want. Okay, so that might be helpful because we have seen this is the 4th question in the same paper about KMnO4, right? And last few questions are there. So X and Y are respectively in the following reactions are what? Okay, so in order to convert into bromination of this benzoic acid, we need to use, see, benzoic acid like carboxylic acid is electron withdrawing group, so electrophile goes to meta position, that we know. So iron, like something like Lewis acid, here iron we can use metal. So in the next bromine, Br2, so bromine, iron for first one, and here methoxy group is electron releasing group that will direct the electrophile to this para position. So we can use here what, bromine with some iron metal we can use, or something like acidic medium we can use. So this is the most appropriate one, bromine with acetic acid. So bromination takes place at para position. So 4th option is correct for this. Okay. So the reagent and organic compound required to convert ethyl bromide, let us say, to 2-butanone. So this is a 2-butanone. So how do we convert here? What are the reagents we can use? Okay, so ethyl bromide is there. So upon treating this with, see, magnesium is there, no? So let us treat with magnesium. Okay, so we will be getting Grignard reagent ethyl magnesium bromide. Okay, so now this ethyl magnesium bromide, ethyl is having negative charge and this will be having positive charge. So now our ethyl is strong nucleophile. Okay, so now this nucleophile can react with this and convert directly this and this to alcohol. But what we required? Ketone is required, right? So it means only one time nucleophilic attack should takes place, not the twice. If it is taking twice, we will be getting alcohol, but we don't require alcohol, we require ketone. So it means the nucleophilic nature should be reduced. So when we treat this with cadmium chloride, we will be getting cadmium, diethyl cadmium. So we will be getting ethyl 2 times diethyl cadmium. So this is a reagent. Now using this reagent, if I take this CH3CO, this CH3COCl, CH3COCl. So now what happens is ethyl anion will comes and attacks on this, which is a nucleophile, attacks on this electrophilic center, chlorine goes out. See, we are getting methyl, so ethyl is coming, this is what the ethyl. So we got the final product. So which is the best option? Option number 3, one of the very interesting question, like conceptual question. Okay. Next, this is also very interesting question and very important. You will be seeing this in all your competitive exams, whatever the exam you are writing. So there will be this point, like carbylamine test, Hinsberg test. These are the organic reagents, practical organic chemistry reactions where you will be doing in the labs. Okay. So an amine X unheating with chloroform in ethanolic forms a foul smelling. So carbylamine test is given only by primary amines, product formed is isocyanate, and it will be having very foul smell, bad odor here. Okay. So let me take a primary amine to understand more clearly. So primary amine means R, okay, on nitrogen only one alkyl group should present, okay, remaining 2 should be hydrogens. Okay. So upon treating this with chloroform in basic medium, it will gives RNC. So this is isocyanate product. Okay. So this is what the carbylamine test, this is what the product form. It will be having foul smell. Okay. So now only primary amines will react. Okay. So this is primary, this is also primary, that is fine, and they both can react. So let's continue our discussion. Y, the product of Y of another amine Y, this is our X, Y means another one they are saying. Okay. And benzene sulfonyl chloride. So this is what amines with benzene sulfonyl chloride is Hinsberg test. Okay. So this is given by primary and secondary amines. Okay. So primary amines with benzene sulfonyl chlorides forms a product, and that product upon treating with basic medium like alkaline like KOH, like alkali medium, so that will be soluble. Okay. Which one? Primary amine will, the product formed from primary amine and benzene sulfonyl chloride will dissolve in the, which will soluble in the alkali medium, whereas secondary amine will react with the benzene sulfonyl chloride and form some product, but this product will not soluble in the alkali medium. Okay. So from this statement you can read Y and benzene sulfonyl chloride reaction takes place, is insoluble in the product of the other amine Y and benzene sulfonyl chloride will be insoluble in the alkali medium. It means this is secondary amine. So one is primary amine, other one is secondary amine. See, this is primary only, this is also primary, this is not the correct one. But in the second option, one is primary, other one is secondary. So this will be the most correct appropriate answer. Okay. So this is done. Yes, we are done with the question paper of EAPCET 29th shift. Okay, 29th morning shift and evening shift, both are done.